Okay, so who am I? My name is Akif Kamal. I'm Director of Engineering in Darwin AI. We are a deep learning product development company in Waterloo. I started my career as a software engineer and then transitioned to data scientist and then to deep learning developer. So I will be covering some parts of my challenges that I face when I transition from software engineer to machine learning, and then how I'm seeing the challenges in enterprises as an executive in a deep learning product development company. So when I started working as when I started learning machine learning, the initial challenges that I faced were like which model to use, how to use the compute power, how to get the necessary compute power. When we talk about the model development, like if I want to develop a model for classification, should I use Inception, V1, V3, ResNet 32, ResNet 50? Should I develop my own model? So the biggest problem or challenge that I have at that time is to find the right model for my application. I can easily get the data online through public repositories, but finding the model or finding the right code to develop the model was one of the biggest issues. But when I transitioned into the production, when I started working as a product company and started developing the products for organizations, I realized that these are not the main challenges. This is a typical machine learning pipeline. I took it from a paper from NIPS. Previously, it was called NeurIPS, one of the biggest AI tax events that happen every year. This paper was released by Google. So they shows a traditional or typical ML pipeline. You can see that the amount or the box size for ML code is very small. So the box size represents the time and effort that companies spend on that specific task. And the color represents the complexity of that task. So usually, like we say that developing an ML model is the most complicated task for deep learning or machine learning or AI. But in reality, companies usually spend 5% of their total ML efforts on model development. Rest of the efforts and budgets goes to different areas of ML, of AI. The biggest one, as you can see, is the serving infrastructure, like when the models will be executed, so finding the right hardware, procuring the right hardware, deploying on that hardware, finding the operational requirement. You can also see the data verification, data collection, feature extraction, which all three are related to data, constitute a biggest chunk of the ML pipeline, along with configuration, which constitutes like training your model or finding the right policy or meeting your operational requirements to deploy your model on an edge device. Challenges. What are the challenges that I notice that are the biggest one right now facing the ML sector? The biggest one is data acquisition and preparation. Then we have ML platforms, model robustness, trustworthiness, and productionization. I will go one by one and I will provide details how we are helping in these different challenges. Data acquisition, like the biggest budget in the MLs usually go in acquiring the data and labeling the data. You need a human to sit and watch a screen. For example, if you are solving a vision problem, find the different boxes and label them. Labeling means drawing the box lines and finding the labeling it with a correct label for that particular class. If you see the ImageNet, there was a paper published by MIT like last week or last week on that 10% of the total data in ImageNet, which is the biggest public data set available, has multiple objects in a picture, which is used for classification problems. So the labels were incorrect. They are not right that are used. And most of the research that have been done in the machine learning sector, especially deep learning vision sector, is on data sets like COCO and ImageNet. So if we have wrong labels, like human making the mistakes, your model will not perform really well. It will have bias. We have seen the data biases coming up on few occasions because the labeling was not the right thing. But getting the label data is a big thing, and how to quality assure your data, how to make sure that the data is properly labeled, it does not have biases, it does not have ethical issues, it is not missing the labels for some objects. Normally, it is done by a human or someone going through the pictures, taking a sample of the pictures and going through the sample of the labels and saying that whether they are correct or not. But the data is usually terabytes of data or petabytes of data. So it is not easy to go through all. Even the sample that is used is very small for verification. So there are some companies which are trying to address this data set problem by coming up with the strategies for data reduction. One of the common techniques that is currently used is active learning. There's a library, for example, Mod AL, plus there are companies like Electio, Snorkel, which have come with the different techniques to data set reduction. But they still rely on the availability of data. They go through your data, find the data that is most appropriate, so saving on the compute cost as well as training time, and then training your data model on those compressed or limited data set. Thus, your model performance will be better, but still you need to spend millions of dollars on getting the data. There are other products like available like Amazon SageMaker, Ground Truth, Labeling, Scale AI, and others, which use ML to do your labeling. So how they work, they expect that certain amount of data will be labeled. Once you feed the labeled data and then you put the unlabeled data, they start labeling the unlabeled data for you using a machine learning model that they have trained using unsupervised learning. But again, it is an ML model that they have trained based on your labeled data. It may have issues, so your data labeling issue will still exist. So in short, like data acquisition preparation, it is still a problem. There are techniques available, there are frameworks available, but it is something that has not easily been tackled right now. And it will take the machine learning industry some years to come up with a strategy that can help avoid these data biases and everything. As per the ML component that I cover, another big issue is ML platforms. Which platform should I use? Should I go with a cloud versus on-premises? Just like the normal software engineering lifecycle, there's ML ops, where in software engineering we have DevOps, in machine learning we have ML ops. Having a system which takes care of from the data initiation phase to the deployment and to the monitoring and to the feedback path. So how to come up, which system to use? During the AI peak during the last few years, we have seen companies developing their own ML ops systems, like Uber has their own, Cruise has their own, Audi and BMWs, they have their own systems. But now we are seeing big players releasing the products to address the ML ops. We have OpenShift from Red Hat. We have Azure Machine Learning Studio from Microsoft. We have a SageMaker from AWS. Google has its own ML ops platform. We have on-premises from DataRobot or H2O. So ML ops, just like the software engineering, now we have different systems already available in the market, both for cloud versus on-premises. One thing that is still a big issue is like frameworks. Which framework should I use? Should I cover PyTorch? Should I go with a TensorFlow, ONX? Frameworks are just like the languages that we use for software engineering. Like, should I develop in C# versus Java? So there was a time when there was a contention. People used to pick one or the other. But now when people are moving their models to the production, there are so many compilers available which will translate your model into something that can work on that specific chipset. So developing a model within TensorFlow, PyTorch, ONX is now not a big issue for deployments. It has become more of a preference for the researcher who is working on this. So this is something that will die out, and you will see people not worrying too much about whether they should use TensorFlow or PyTorch or other models in their development. So ML platform is something that I feel is like will be addressed by this industry in the next 1 to 2 years, which has already been addressed. We have already seen hundreds of platforms available, and this will not be an issue going forward after a couple of years. This is one of my favorite issue, which is model robustness and generalization. Like, you have your model which has an accuracy of 99% on training data set. You use your test data set to verify it. You have an accuracy of 98%. You launch in production and you will see performance drop to 80% or 85%, because you always have unseen scenarios which are not covered as part of your test data set and training data set. It is not easy to find all possible real world scenarios or expect your model that it will adopt itself. That is why we have a concept of generalization in machine learning, where you try to make your model generalize. This is something that there are so many techniques available, but still there is no rule of thumb which will ensure that your performance of the model will be same in production. You will see, especially that's why you see that it takes longer for autonomous vehicle or drones or AI in the medicine sector to be released, because they always have challenges when they try do the clinical trials, or when they try their models in the on the roads for autonomous vehicle. Usually the performance is not that good. It is something which will evolve during the passage of time. Another thing that we have seen is adversarial networks, or adversary for ML, where people like, if I'm going through a face detection model, I can wear a certain mask, or I can wear a certain T-shirt, which can make the model detect me as an animal rather than as a human or something else. So you can easily trick the models. So we have seen in the recent years adversarial networks coming in the real life more and more. For that, now like deep learning industry is going, we want to use multiple models and cascade these models using NAS approach to overcome this. So NAS models will become more common just to cover up and to resolve the issues with vulnerabilities. How we are going to do what we are doing in Darwin, we are one of our products is AI explainable AI, XAI, where we want to help the developers find the issues in their machine learning models and data, and help them to make their model generic enough so that it can work in real life with the data that they have not seen, as well as provide the interpretability for their models. So for example, this is an image from one of our papers that we published a couple of months ago. Basically, we took a COVID-19 model that was developed by some organization on CT scans on COVID patients, and they claim that they have an accuracy of 90%. When we pass the results of their model through our AI product, we noticed that the model was looking at the bed, not at the actual lungs. So basically what they did, when they were screening the normal patients, the bed was okay, the normal one. But when they were screening the patients with COVID, they used extra lining. They put extra layer just to make sure that it does not get the germs as well. So their model learned to detect the COVID patients based on the extra layering on the bed, not based on the lungs. So they have a high accuracy because all the COVID patients that they scanned, they have the extra bed. So the model was giving the right results for the wrong reason. So this is one of the things that we have seen. Like there was another customer where we were working with, they have autonomous vehicle. Their concern was their car used to turn more often right whenever it is like during the sunset time. So we identified that the car correlate. Basically, when the car was trained, the driver used to take out the car from the garage, and during the evening, they used to bring the car back into the garage. But when they were bringing the training cars back into the garage, they have to take 4 right turns. And usually the time for coming back is around the sunset time. So the car correlate the color of the sky with turning right. So it started turning right whenever the color of the sky changed to the sunset time during that time frame. So sometimes you have the models that make the right decision because of the wrong reason. So finding these wrong reasons, making sure that your data is robust enough to cover all the cases, as well as if there are bias in data in your model that can be fixed, it is a big issue. And we are trying to address with our product. Now, last 2 slides I will try to cover during the next 5 minutes. The last one of the biggest issues that we have seen is productionization of the models as well. Like we have, for example, super resolution models available, which make your resolution of the screen super crisp when there are pixel issues in your pictures. But if you see the modern TVs, they still don't have employ these super resolution models. Although companies like LG, Samsung, they are already working on super resolution model. They have published papers on super resolution model. But why they are not using them in their TV screens? Why they are not using in their monitors? It can be a good sale where most of the people are using the streaming their channels. So they can say that irrespective of your bandwidth, you can always get the super crisp resolution. What is the reason? The reason is like these models, which gives you the best performance, state-of-the-art performance, they are very deep models. They require too much computational power. They consume a lot of energy. They also generate heat. So if you use these models in your TV, you may be using your TV as a heater rather than actual TV because of the heat it will generate. So deploying your machine learning or deep learning models on the edge devices is a big issue. As per the survey done by Algorithmia, like normally organizations spend between 31 days to 90 days to deploy their model. Once they have prepared their model, once they have meet their performance requirement, it takes them 90 days around. This is a median time frame. Some companies even take more than a year to come up to optimize their model to meet their operational requirements so that they can fit into edge devices. 22% of the companies, they never meet their operational requirements. They have to go back and they have to develop a smaller model. So this is another big challenge facing the deep learning and machine learning industry. How we are helping with it? Another product that we have is Jensen, which helps in model generation. How it works? Like you feed your own trained model, which you have developed. Currently, we only support deep learning models, vision-based problems specifically. When you feed these models into our product, we'll give you an optimized version of a model, multiple optimized versions of the model that will give you same accuracy, but requires much less computational complexity. And the size of these models is much, much smaller. So, example, this is an example for refined on the Cambridge data set, which is a state-of-the-art model available on the paper. The performance of this model, as per the paper, is 80.11%, and the flops, which is the floating point operation, which is an indicator of computational complexity, is 404 billion flops there. The models that we generate, one of the model that we generate, it has a performance of 82.2, so 2% higher than the state-of-the-art model published in the paper, but the size of that model was almost 20 times smaller than the published model. So we use a combination of distillation as well as pruning and as well as NAS-based search to find the best model. So the idea is like there are products available, and we are trying to be leader in those sector to help the companies reach to their productionization target or operational target much faster using a more streamlined product, as well as helping them to make their models work in unseen cases, may identify the biases in their data as well as the inefficiencies of their data, and finding what kind of data they need to train their model best. That's it. My last slide is from a deck from Ed Fernandez. He is one of the investors, a VC investor in San Francisco. He did a presentation last year, towards the end of last year, on the trends of machine learning. One of the things that he mentioned that auto ML and auto DL, which we have heard during the last few years, was a big trend during the last 5 years, where we have seen many ML models and platforms coming in the industry. You have so many models available to use. Now this is a trend that is dying out. It has become more of a commodity where you can easily pick a model, you can easily use a product. The new trends in the machine learning will be addressing the knowledge representation, addressing the explainability in AI, and coming up with an optimization strategies where you can easily push your trained models into the production or into the edge AI. That's it.